Okay, so today we're going to take a little bit of a left turn and talk about something called BCG. I work in urology, and this is something that's used for patients that have bladder cancer. And I'm certain most of you guys have never heard of this before, at least for bladder cancer treatment. So I thought, let me make a video so we all can learn what this is. I think it's really interesting. Hopefully you guys find as much interest in it as I did. So let's get started. So in order to talk about BCG, we got to understand bladder cancer. So what is bladder cancer? Bladder cancer is a type of cancer. We know that cancer is when we have a mutation in our cells that cause them to rapidly divide out of control. And this cancer begins in the cells that line the wall of the bladder. So if we zoom in here, this is what bladder cancer looks like, at least in its early stages. It kind of looks like corals, just kind of floating around in there. And this is seen through a procedure called a cystoscopy. The doctor takes a scope with a camera into the urethra to kind of look and see what's going on. This is a illustration of it. And just like all cancers, it has stages. So I have a link to the American Cancer Society website that has all this broken down. It's a lot more complex than this, but I wanted to boil it down. So stage 0, I guess you could say, is precancerous lesions, cells that are starting to express that potential for cancer, but that aren't quite cancerous, at least in my understanding. Then stage 1, one of the early stages, is when you have the cancer that invades the connective wall tissue, the connective tissue that lines the bladder wall. This is distinct because it is not an invasion of the muscle. So we go over here, this over here is really an early stage. It's kind of floating around. It hasn't clumped up together like here. This is when it gets into the muscle. So stage 2, this is when it goes deeper and invades that muscle. Then stage 3, it could travel or migrate to the local organs. Lymphatic tissue or system is a system in our bodies that delivers white blood cells and things like that. Then the last stage, it could get into the major organ systems. And most late stage cancers will spread to the body if it has an opportunity to. So let's get into some anatomy, some male and female anatomy, to kind of give you guys an idea of how this cancer can affect the different organ systems, depending on if it's a man or a woman. So it's important to note that cancer of the bladder is more common in men than in women. It's less common in women. And both men and women have ureters. These are connected to the kidneys where the urine is drained into the bladder, but there's some differences, of course. So, this urethra extends in men, and that's the penis, and the opening is the opening to the urethra. And at the base of the bladder, wrapping around the bladder, is the prostate. The prostate gland is one of the male sex organs, and women do not have prostates. What women have is, bladders like normal, ureters that drain, but there is the vagina, the uterus, the ovaries. There are a lot more sex organs in the area. Now, I brought this up because if bladder cancer does spread, you can see the organs that it could spread to. Now, men, we have our prostates, and prostate cancer can be common in men. But with women, it can spread into these other very sensitive systems. And I just thought that was important to bring up because in understanding bladder cancer, it's important to understand the surrounding area that the cancer could get to. So what is BCG? BCG stands for Bacillus calmette-guerin. I don't know if I pronounced that right. It's named after the scientists who discovered this, and this is an immunotherapy, a treatment that uses our immune system to fight against a pathogen. And this comes from a strain or type of Mycobacterium bovis, a tuberculosis in cows, and it's used as a tuberculosis vaccine. And this is a human tuberculosis vaccine. Over 4 billion doses have been given, and it's what's called a live attenuated vaccine. Live as in it's the active pathogen, attenuated as in it's a weakened form of the pathogen, in this case the bacteria. And this is very different from human tuberculosis, Mycobacterium tuberculosis, which causes a nasty disease, which we'll talk about in the next slide. But BCG is used as a vaccine for tuberculosis, which is interesting because it's also used for bladder cancer. We're going to talk about that in the last slide. So let's talk about tuberculosis, just to kind of give a refresher on what it is. So human tuberculosis, it's called TB, is an infection caused by the bacterium Mycobacterium tuberculosis. It can affect a lot of body systems. It mainly affects the lungs. It's spread through what's called respiratory droplets, coughing, sneezing, stuff like that. An active infection can produce symptoms like coughing up blood, night sweats, weight loss. And weight loss is interesting because it used to be called consumption. At least the old school word for tuberculosis was consumption, because it If you have tuberculosis, oftentimes you can have a dramatic weight loss. So it was thought that this was consuming you from the inside out. And it can also result in chest pain. So tuberculosis is a pretty nasty bacteria. It's not common in developed countries, but it is still around, which is why it's necessary to have a treatment for it. So let's finally get to the topic of the video and talk about how this BCG vaccine is used for bladder cancer. Okay, so I got this little illustration from an article in Nature magazine, the journal Nature, and I'm going to put it in the description because I think it's very fascinating and I think it explains things well. It can be a little complex. I'm going to try my best to boil it down. So BCG is a non-specific immunotherapy. So we know immunotherapy is using our immune system as an agent to fight against a pathogen. And it's non-specific in that it doesn't specifically target the cancer. It just happens to produce a response that can kill the cancer. But it is important to note that this is for non-muscle invasive bladder cancer. If it gets beyond that stage into the muscle, there has to be more aggressive treatment depending on how fast it's spreading. So let's break this down into some stages and go through some terms. So let's go to A here. So we have our cancer right here. And these little squares are the bladder cells. And this cancer comes into contact with BCG. And the BCG attaches to this stuff called fibronectin. So what is fibronectin? Fibronectin is a structure that allows tissues to attach to things. In this case, it will allow the cancer tissue to attach to the bladder wall. And when it attaches to fibronectin, a couple things happen. These complexes get expressed. MHC1 and 2, it's called major histocompatibility complex. In general, again, all this stuff is going to be a general definition. These present antigens for T cells to look at. So, what are antigens? Well, antigens are pieces or parts of foreign substances used to initiate an immune response. You can think of them like a bright light in the darkness. And this is what immune cells see so they can determine like, okay, this is what we're looking for and this is what we need to kill and attack. And we're gonna talk about what T cells are in a second, but let's go to B. So B, it's important to note that in this section, the environment of the cancer cell is changing. So here's how and why this is important. It's important because when the immune system starts to kick in, you'll see all of these immune cells springing into action, doing all their various tasks and eventually, hopefully killing the invader. So we have these things called interleukins. This is what is IL for. So we have 2, interleukin 6, gamma, 7, 8. I could spend an hour talking about interleukins in general, but importantly, we need to know what they are. So think about wartime. I know nothing about war, but we know that we need to communicate. If you're in the war, you need to communicate to your forces. Okay, we need air support, we need ground support, we need this, we need that. Interleukins offer this communication to allow for immune cells to do things like migrate. Migration is in it sends messages for immune cells that are needed to come to a certain location. It assists in maturation. Sometimes immune cells need to be sprung into action. They need to go through changes to turn into other things so that they can then attack or do the job they need to do. It also assists in things like differentiation. I could say multiplication. We not only need cells to help, but we need a lot of them. So interleukins help multiply, well, at least aid in the process of multiplying certain cells. And then we have neutrophils and macrophages. So over here, these do what's called phagocytosis. If you've ever taken general biology, you kind of know where I'm going. These cells will consume the pathogen, eat it up, and dispose of the remains. Now, macrophages are important because these are professional antigen-presenting cells. Spelled it wrong. Anyway, if you recall, we spoke about how antigens are pieces of foreign substances. So in this case, this macrophage will use an MHC, a complex, to stick that antigen up on its surface and say, hey, this is what you need to kill, this is what you need to attack. And that's how the immune system can operate. So certain cells present these antigens so that the helpers or the killers can see what's going on and decide what they want to do. Then we have the T cells. So we have our CD8, CD4. These cells are really some of the active players. The CD8 cells are what's called cytotoxic. They're the killer T cells. They're cells that will seek and destroy their target. That's why the MHCs and the antigens are important, because these cells look around and they're like, okay, this is what I need to kill. I'm going to kill that. Then you have the CD4 cells, the helper T cells, and these help. They assist in attracting other cells to come in and elicit the proper response to whatever the pathogen is. And at the end of the day, the whole goal is that these cells will come in and kill the cancer and destroy it and keep it from spreading. And these treatments are given consistently as the patient needs it. So I talked a lot. This was a little complex slide. So let's go through the summary and review what we talked about today. So we introed bladder cancer. It's a cancer that begins in the cells that line the wall of the bladder. There's different stages, and BCG is needed for some of the early stages of this cancer. Then we talked about some anatomy and how men and women have different sets of anatomical features that are of importance when it comes to bladder cancer, because if it does spread, it could spread to these local organs, which is why getting treated is important. And we also mentioned that bladder cancer is more common in men than in women. Then we talked about BCG, how it's a vaccine derived from a strain of tuberculosis, and it's used for prevention of tuberculosis in developing countries. Then we talked about BCG, how it is an immunotherapy that comes from a strain of tuberculosis, and it's used mainly as a vaccine for human beings. That is an active but weakened form of the bacteria. Then we talked about human tuberculosis. It mainly affects the lungs. It's spread through coughing, sneezing, and it has a whole host of nasty symptoms. And this BCG treatment is used for this disease. And then we talked about how BCG is an immunotherapy for bladder cancer that has not gotten into the muscle of the bladder. All these complex immune cells and processes that are used to recognize the danger and the pathogen and to attack the pathogen, certain molecules like interleukins that assist in communication, and you have cells that present those antigens, those pieces of the foreign substance that allow the immune system to recognize and destroy the invader. Then we talked about T cells that can destroy or offer help and assistance in this very complex attack on, in this case, bladder cancer. So that's all I got. I hope you guys learned a lot. I hope this slide specifically wasn't too complicated, but I think it's important to know how this stuff works. Like I said, I'm going to post the American Cancer Society link and the Nature paper in the description for you to go through it. I learned a lot doing research for this video. As always, thank you so much for watching and listening. Please like, comment, and subscribe. Tell your friends, and I'll be back soon with another video.